Okay, here's some more examples for exponentials. So A, I'm going to do right here. This graph goes with B. So A we'll do right here, and it says, I have a really dull pencil, but we'll live with it. It says, on the same set of axes, graph y equals 5 to the x, and y equals negative 5 to the x. So remember that negative is just sitting out there, and it's 5 to the x, and then make everything negative. All right, so 5 to the x. When I put in 0, I get 1. And when I put in negative 1 for x, I get 1/5, so really close there. And when I put in, 1, I get 5. So this is what that's looking like. Not perfect, but okay. All right, that's y equals 5 to the x. I want to label those. And then negative 5 to the x just means every value I got up here is negative. So it looks like this. So when I have a negative out the front, the mirror image is over the x-axis. I think that's we were used to that. Okay, B is right here, this graph, and it says give a possible equation. Well, it looks like the mirror image of this one, so I could say it's y equals 5 to the negative x. Yeah, that's that one. Mirror image over the y-axis. Okay, now let's look at this. I might use a pen just so it shows up on this graph. So it says this is a graph of y equals 3 to the x, and we're doing vertical and horizontal translations. So horizontal is when I have, it used to be in the brackets. So y equals 3 to the x minus 2. So I'm going to go 2 to the right. Remember, a negative up here makes it go right. So I'm going to take this point and I'm going to take it 2 to the right. And I'm going to take this point and take it 2 to the right. And then I can see that it's going to look just like that curve, except 2 to the right. And then a vertical translation for this one is going to go down 2. And I kind of didn't leave enough space. 1, 2. Okay. And that goes down. And so my asymptote, which I kind of have missing there, is right there. I could do it in blue. Okay, and this one's going to go down 2. And so this looks like, so it got shifted down 2. So when it's the number off the end, it's shifting down or vertically. All right, now, I don't want you to get too worried about these dilations. They're mostly going to be calculator things, and all this dilation stuff we didn't really talk about that much before because we said we were going to use it with trig. But let's just have a look on the calculator of y equals, that was somebody else, 2 times 3 to the x, and I'm sure you can see what's going to happen. And you know what, I'm going to put y equals 3 to the x on there as well, so you can see the difference in the two graphs. So the blue one's going to be the one we want to graph, and it's a dilation of 3 to the x. So let's just graph that. And there's the blue one. That's the dilation. And here comes 3 to the x. It looks almost the same there, but it's just not so steep because I'm not multiplying every value by 2. So I'm sure you could have figured that one out. Okay, and then maybe this one, we'll graph y equals 2 to the x. And then up here I'll graph its dilation, which is 0.5 times 2 to the x. So the red one is the original, let's say, and the blue one's the dilation. So there's my dilation, that's that. You know what's going to happen. Yeah, that half just slowed it down. So that's what we mean by dilation. It just gets kind of either fatter or thinner. All right, those are your problems, 9.2 exercises. You can use a graphics calculator for those two. Ms. Weidel made a nice presentation. So if there's any questions you have about this one, then about what the notes we took, then use this. All right, bye.